This is Professor Pelton. This is Algebra 2, Chapter 7, Section 2. This is Part 5 of the video. So if there is any cancellation for holes, you should do that immediately in the problem before going on. So that's the last thing we have to do here. So if you look at our problem here, this is y equals x plus 3 over, and if you think about this, this is x squared plus 0x minus 9. You're missing a middle term there. So if factored, I get x plus 3 and x minus 3, giving me negative 9 when multiplied and 0 when added. So those cancel, giving me y equals 1 over x minus 3 is our new simplified function. Okay, so as far as an intercept goes, we know x must be 0. So if we plug in 0, I get y equals 1 over 0 minus 3, hence negative 1/3. Okay, so that's what C. 0, negative 1/3, that's about right there, I guess. Not quite there, but good enough for this. Okay, so X-intercepts. I know I have to have 0 for y. So 0 equals 1 over x minus 3. I'll make that a fraction so I can cross multiply. So this way I get 0, and this way I get 1, which is not true, which means there are no x-intercepts here. Okay, so as far as vertical asymptotes, the x minus 3 cannot be 0. Therefore, x cannot be 3. So x equals 3 is the vertical asymptote. Okay, but there's also a hole because the x plus 3 canceled. That also cannot be 0, so x cannot be negative 3 when you solve that. So we have a negative 3 comma something as a hole somewhere. So if I plug it into the equation, I get y equals 1 over negative 3 minus 3, hence negative 1/6. Okay, so horizontal versus slant. What do we have here? Well, regardless of which one you plug it into, y equals 1 over infinity minus 3. It's just essentially 1 over infinity. And you can't, if you divide anything by infinity, you essentially get 0 because you nuked it. So y equals 0 is the horizontal. Therefore, there cannot be a slant because it's one or the other. So you have y equals 0 is your horizontal. Since I knew the y-intercept, that means it has to go on the bottom side over here. There can't be anything up here because it would not pass the vertical line test. Okay, so that has to be blank up there because it's one or the other. You can plug in points to verify. We have 1 point, and this is bad right here because it has to approach and not bend the other way. So you can be very careful on that. Okay. All right, so over here on the right-hand side, it's either going to be up here or down here, but not both, because it has to pass the vertical line test. So we'll just plug in some value down over there to figure out where it is. Since my vertical asymptote is 3, we'll just plug in 4. It makes logical sense. So we have y equals 1 over 4 minus 3 equals 1 over 1. So you plug in 4, you get 1. Okay, so we go to 4 and we get 1. So we get this graph right here essentially. Okay, but this is still incorrect because we have a hole. At negative 3, 1/6, because this keeps going this way, right? At negative 3, 1/6, you have a hole, right? So that's negative 3, 1/6 negative. You have a hole there, okay, which can't be seen in a calculator, of course. So let's go to the graphing calculator and look at that real quick. So even if we put the original x plus 3 divided by x squared minus 9, I get the blue graph. menu, graph entry, function. If we put the simplified version, 1 divided by x minus 3, watch closely to the blue line. Boom. The red's just covering it because it's the same graph function. And what you notice is we have y equals 0. Here the y equals 0 horizontal asymptote. And the x equals 3 vertical asymptote. And if you look here at -3, -1/6, it looks like there is a point there, but it's infinitely small, so you can't see it. But if you look at the table value, table split screen, if you go to -3, undefined. All right, pause the video and try the student problem for yourself. Okay, for the student problem, simplify first. So y equals, that's really x squared plus 0x minus 4 over x minus 2. So y equals factored x minus 2, x plus 2. We'll multiply the -4 and add to 0. So y equals x plus 2 is our simplified function. Okay, so if I plug in 0 for x by definition of a y-intercept, because all x is 0 for y-intercepts, I'm going to get y equals 0 plus 2. And we'll put our point up there. Okay, x-intercept by definition, y is 0, so 0 equals x plus 2. So x equals -2. Okay. Vertical asymptotes, well, we don't have a denominator, so there's going to be none. But the x minus 2 is canceled, so x minus 2 cannot be 0, so x cannot be 2. So it's got to be 2 comma something as the whole. So if I plug that in, I get y equals 2 plus 2. So thus I get 2, 4 is a whole. So I go to 2 and 1, 2, 3, 4, and I put a whole. So horizontal and slant asymptotes. So if I plug in infinity, I get y equals infinity plus 2, which is just infinity, which means there is no horizontal asymptote. It's slanting towards infinity, right, on an upwards line. So essentially I need to do long division. And if you did long division using the original problem, watch what you get. All right, so the first multiple is x, so x times x gives me x squared. X times -2 gives me -2x. So if I subtract, I get 2x minus 4. So my next multiple is 2. So I get 2x minus 4, and I get no remainder. So my slant asymptote is y equals x plus 2. So my slant is the simplified function. Okay. So again, every point is going to fall on that asymptote because slant and horizontals, you can be on those asymptotes. You can cross them. This is the direction that you're following as you follow infinity. So essentially, this is the line, which is a y-intercept of 2 and a slope of 1 over 1 with a hole in it. So if you tried to graph it in the graphing calculator, so we have x squared minus 4 on the top, and on the bottom x minus 2. We get our, oh, I didn't use parentheses, my bad, I'm sorry. I use parentheses, that is bad. There we go. Perfect. And it looks like it's solid, there's no hole, right? But if you, again, that's going to be infinitely small points because points don't have sizes. Basic geometry concept. At 2, we are undefined, right? It goes 3, undefined, 4. There's a hole there, basically. Okay. That is the end of part 5.